Dear students, we have understood the meaning of double integrals in the case of limits as constants and limits as variables. In the present discussion, we will extend the same ideology in discussing about triple integral, how these triple integral behaves even for the applications in the case of more than one dimension and more than two dimension with the three variables we are going to include, that is triple integral with respect to x, y, z. Here all the three integrals, that means so far what we discussed in the case of double integral, together we call it as multiple integrals, but in the case of double integral already we discussed about the problems, how this two-dimensional Cartesian coordinate system and polar coordinate system will behave. In the case of Cartesian coordinate system, that is with respect to the variables x and y inside the double integral, and the derivatives dx and dy. And we discussed the problems with two types of major limits. One is set of limits as constants, both lower and upper limits, and set of limits both lower and upper limits as variables. Always I told you that the outermost integral carries the constant limits and the innermost integral will carry the constant limits or the variable limits. So, in the present discussion, that is in the today's lecture, we will discuss about the triple integral with variable limits and constant limits and the applications of this multiple integral in the engineering problem solving procedures. Now, let me start with triple integral in the form of constant limits as first problem and variable limits. This is the case of constant limits, that is minus c2 plus c, minus b2 plus b, minus a2 plus a, x square plus y square plus z square should be, it is denoted as dz, dy, dx. In the case of constant limits, already I told you that it can be discussed with respect to the given order as it is, but in the case of variable limits we cannot do like that, but here it is, for example, according to this order, that is dz, dy, dx, and dz, dy, dx will carry, that is outermost integral, this one, that is with respect to the variable as dx, and the middle integral is with respect to dy, and the innermost integral, that is z equal to minus a and z equal to plus a, will be the variations for z. This is called I equal to triple integral x square plus y square plus z square dz, dy, dx. Then how this triple integral will go for constant limits. These are arbitrary constants, we call them, and particular constants, one example I will solve, arbitrary constants, another example I will solve, and variable limits, one or two cases we will discuss. Then we shall start the applications of this multiple integral in the case of double and triple integrals, that is for finding two important applications. In the case of double integral as area, which is bounded between the given boundaries, we call them, that boundary is going to be formed between the intersection of two curves geometrically on the x axis and y axis, and another one is volume, when the particular given curves are rotated, so a certain shape of this solid is going to form. Then that particular solid will give us the calculation of volume by means of double integral. Similarly, in the triple integral, that is with respect to three variables, we will end with by studying the volume by means of triple integration. Now, let me solve the problem, the triple integral problem, with in the case of that is constant limits, that is particular constants, then arbitrary constants. As I told you that, then the variables, limits as variables, will try to understand. The problem is, that is the triple integration with the limits, that is 1 to 2 0 to 1 and minus 1 to plus 1 x square plus y square plus z square, it is dx, dy, dz. This is the case one sample according to this triple integration. We declare these constants which are given in the present problem are constants, particular constants. Then the order is given, that is dx first, dy next and dz next. We will represent these by means of inequalities, how these limits are going to be designated for the individual integral. So, in this solution we take, let I is equal to integration 1 to 2, 0 to 1, minus 1 to plus 1, x square plus y square plus z square dx, dy, dz. What we do here, according to the given order itself, given order means dx first, dy next and dz for the outermost integral. For the dx, here we represent this as x, middle integral, this is for y, and outermost integral, that is for z. How further we can understand, further some details we can designate for this problem, it will be like this. Actually the outermost integral, anyway innermost integral if you start with, then minus 1 less than or equal to x, less than or equal to plus 1, 0 less than or equal to y, less than or equal to plus 1, and 1 less than or equal to z, less than or equal to plus 2. This is alternate way of representing the limits for the given integral. That means here the problem will be taken, the solution of this problem will be taken according to the order dx first, then dy next, then dz as the third integral. Then I is equal to this one, integrate with respect to, you cannot choose, please remember one thing, you cannot choose the outermost integral first, then innermost integral, middle integral, then innermost integral. You cannot choose like that, because in the previous discussion already we have designated this by means of figures. This is first box, this is second box, this is third box, which go for this triple integral. Already in the previous discussion we have understood about the two boxes which were represented for double integral. Now this is triple integral x square plus y square plus z square, this one, that is dx for the innermost integral, then outermost integral dy, then middle integral, then outermost integral, it is dz. Accordingly, this is for innermost integral, this is for second box, and this is for third box, like this. The application goes like this. You have to integrate the innermost parenthesis first, then its adjacent parenthesis, then it's the outermost parenthesis. This is the way you have to take the integration. Now integrate with respect to x. Then what about y and z? At that time treat y and z as constants, that means temporarily constants. Now you will integrate term by term, that is x square, y square and z square. Therefore I is equal to 1 to 2, 0 to 1, then should be x cube by 3 plus, here y square is constant, then you will put it y square outside, then x, plus z square is constant when you are working with respect to x, this one, then z square into x, which we have to assign the limits for the innermost integral, that is minus 1 to plus 1. The remaining derivatives are dy and dz. So this is first integration which you carried out with respect to x, then accordingly you substitute the limits. That means you have to replace x, that means you are eliminating x equal to -1 and x equal to +1 for the innermost integral, that is 1 to 2 and 0 to 1, then x equal to 1 by 3 plus 1 y square plus 1 z square. Then you will substitute or you will replace x by -1. X by -1 means x equal to -1 whole cube, that gives us -1. But please remember, you are applying the lower limit. Lower limit, when you are applying, one more minus sign has to be assigned, then that makes us plus sign, that is plus 1 by 3, and here also plus y square, and here also plus z square. This is application of limits with dy and dz. Further, this is equal to 1 to 2 integration, then 0 to 1. You can do some simplification here before going to the next integration, that is 2 by 3 plus 2y square plus 2z square. This should be dy and then dz. Hope you are following the order of selection for the integration. First is with respect to x we did, then accordingly we are substituting the limits. Now from this step we are going to integrate with respect to y. Anyway, 2 is common, otherwise you can leave it there itself. Then we can write integrate with respect to y. In this case z is constant, then I is equal to, should be 1 to 2 integrating with respect to y. Therefore, this should be 2 by 3 y plus 2 times, it is y cube by 3 plus 2 times, it should be z square into y, between 0 to 1 should be dz. This is equal to 1 to 2. You have to replace that y by applying the limits for which are given for a middle integral. Middle integral means 0 less than or equal to y less than or equal to +1. That means y equal to 0 and y equal to 1. Then y equal to upper limit, that is 1, should be 2 by 3 plus 2 by 3. This is y, and of course 2 by 3 which you are replacing this one by y, and y cube by 3, that is 1 by 3, that makes 2 by 3, and plus in place of y, that is 1 plus 2z square, and minus 0, since y is present in all the terms, lower limit for all the terms will become 0. Then this must be integrated with respect to z. You can see the structure of selection. First you took with respect to x, keeping other two as constants. Next you took the middle integral with respect to y, where x was already eliminated. Then you kept it as z as constant. Now finally we are left with only one symbol. This is ordinary integration with respect to single variable. You can also do the simplification here, that is 4 by 3. I think I can write directly. Hope you can understand directly if I write. That is 4 by 3. Directly you can write with respect to integration as z. So that is 4 by 3 z plus 2 times, it is z cube by 3, and running between, that is 1 to 2. That means z equal to 1 and z equal to 2 is the upper limit. That is 4 by 3 into 2 plus 2 by 3 into, that is z equal to 2, 8, and minus 4 by 3 minus 2 by 3, that is 8 by 3 plus 16 by 3 and minus 6 by 3 should be the answer. That is 3 is the LCM. 8 plus 16, that is 24. 24 means here you can take 18 with plus sign. So, 18 by 3 is your final answer. The evaluation of triple integral, which we selected innermost integral first with respect to x, then middle integral with respect to y, and next integral with respect to, that is z, that means outermost integral. Similarly, we will choose another problem with arbitrary constant as I told you. Then that goes like this. One example we will cover on the arbitrary constant that are a, b, c. Then 0 to a, 0 to b, 0 to c, x plus y plus z should be dx, dy, it is dz. Here in the previous case we had particular constants, now they are arbitrary constants, but both of these cases will go for the selection of the order of derivatives according to the given order, or even you can change and then also you can integrate, the value remains to be same. These are arbitrary constants. Let us denote this one as 0 to a, 0 to b and 0 to c, x plus y plus z should be dx, dy and dz according to the given order. This will be for x and this will be for y, and the outermost integral will be with respect to z. Then integrate, you will write integrate with respect to, that is x. First you will do the integration with respect to x. That means temporarily y and z you are keeping them as constants. Then I equal to 0 to a, 0 to b, then with respect to x should be x square by 2 and y, that is y is constant, x you will put, and z is constant, x you will put. This quantity will be defining between 0 to c should be dy and it is dz. Then you have to apply the limits. Only the upper limits, upper limit will play the role, because for all the three variables, for all the three integrals, lower limits which are given as 0, 0, 0. So only one value you can expect for the application of upper limit in all the three cases. Then this is equal to 0 to a, 0 to b, you are going to replace x equal to upper limit and x equal to lower limit. X equal to upper limit, that is x equal to c, I can write it as c square by 2, and I can write it as c into y, I can write it as c into z, that is the end of application of upper limit, and minus lower limit, as I told you that all the three terms will be leading to 0. This should be dy, then dz. That means you took the integration with respect to x. Now we start with integration. So three variables are reduced to two variables. Now two variables we are going to reduce to one variable. So that becomes a normal integration with single variable. Integrate with respect to y, you will keep z as constant. You will keep z as constant in the order, that is x, next is y, next is z. You can also interchange the order in the case of constant limits, as I told you in the double integral. Same ideology we are going to extend. Then this is 0 to a, 0 to a, then you will integrate with respect to y, keeping z as constant, should be c square by 2 y plus c into y square by 2 plus c into y into z between the limits 0 to b and dz. Then that is equal to 0 to a, then you will replace y by the upper limit c square b by 2 plus c into b square by 2 plus c into b into z, close the bracket, then it should be dz. Further, 0 to a, that is in place of x and y, now we are going to integrate with respect to z. That means two variables already we have cleared. Now the third variable means last variable, outermost integral, which carries these limits as 0 to a. This becomes c square. Anyway, you can integrate, that becomes c square b. Otherwise, you can take 2 common and then you can put it as this one. Therefore, same c square b, that is 2 into 1 you can take here, plus c into b square by 2 into 1, which you can integrate, and plus c into b and z you can integrate. This should be dz. Finally, c square b by 2, that is z, plus c into b square divided by 2 into z plus cb. Here z is there. In the other two terms z was not there, but here z is there. That you can write it as should be z square integration with respect to z is z square divided by 2. Now the limits which are given as for z as 0 to a, you will introduce these limits c square b into, this is a by 2 plus c into b square a by 2 c into b a square divided by 2. This is the end of it, and lower limit for all the 3 variables we have to replace as 0. That means no term will exist when you replace z by 0. The final simplification, you can just take a common solution. Always, you please remember always the possible extent, the simplification we consider in the case of mathematical calculations. Then especially for engineering applications, with any branch you are going to take in as multiple integrals which you are going to do that, then up to which stage you need for the further interpretation, up to which stage, then you can leave the answer up to that stage. But now mathematically we can go up to the last step here, that is ABC by 2 you can take common, and leaving C here and leaving B here and leaving A here. So your answer is ABC by 2 multiplied by A plus B plus C. This is your answer. This is the procedure that we are going to follow in the case of variable limits, constant limits. Now the variable limits case we are going to consider the very important situation, how variable limits will play the role. That means already we have discussed in double integral how these variable limits are to be taken, in which order. That means which variable you have to consider first and which variable. But now as you wish, you can change the order and then you can do the integration and you will get the answer. But in the case of that is variable limits, we have to be careful which variables are given, or which variable is appeared for innermost integral, then which variable is appeared for middle integral, and which variable is appeared for outermost integral. If that is the case, you cannot choose the order as you like, and if the order is given correct according to the limits given, then you can move further to do the first integration. If it is not matching, then you have to rearrange the problem according to the proper order, means which variable appears, then opposite variable you have to consider. Opposite variable you have to consider means if x is given, don't integrate with respect to x. If y is given, don't integrate with respect to y in that particular stage. If a z is given inside, then don't integrate with respect to z. Choose opposite symbol. That opposite symbol, how this problem goes, that let me explain in the next very important situation. Evaluate (0 to 1) 0 to root of 1 minus x square, 0 to root of 1 minus x square minus y square, 1 divided by root of 1 minus x square minus y square minus z square. It should be, sometimes the order will be given correct, sometimes the order is not given correct. Then what it is expected there when the order is not given with the proper matching of the limits. In that case, you need to understand the problem. You are expected to rewrite the problem according to the required order. Then you start writing the first integration, then second integration, like that. Okay. Here, this is the order in the innermost integral. Anyway, limits, this is the case of limits are not constants, which you have to assume, right, because limits are given in the form of variables, that is x and y to the innermost integral, to the middle integral, that is x, to the outermost integral remaining symbol. For the innermost integral, for example, here x and y are there, then immediately you have to assign z. Therefore, dz will act as variable for the innermost integration, and when z is chosen for this, then here x is there, you cannot do the integration with respect to x, then you have to go for y. This is y, and obviously last one is x. Therefore, dz, dy and dx. This is the order. This order you cannot change. This order should be fixed, because which variables are given, opposite variable you have to designate when you start writing the first integration. Then this is the first integral. So z is there, y is there, x is there, and you can assign the inequality values by inequality symbol. You can represent 0 less than or equal to z less than or equal to root of 1 minus x square minus y square, and for the middle integral 0 less than or equal to y less than or equal to root of 1 minus x square, outermost integral less than or equal to x and less than or equal to plus 1. This is the order you have to consider by means of inequality like this, and by means of direct representation of the limits as lower limit and upper limit, it will go like this. Okay. Then this is the order, and these cases, please remember, these cases are commonly occurring. The student is expected to rewrite the problem when the order is not given properly. Then now the order is given properly. So whenever this type of situations are given, then they may you may expect the problems not exactly in the correct order. Then you need to change the order, and then you have to start your integration. That is most expected one. So these are the inequalities. That means you cannot do with respect to x or y for the innermost, you cannot do with respect to x for the middle integral, then obviously that is reduced to x. That means how we are going to take up x comma y comma, z comma y comma x will be reduced to y comma x will be reduced to x. This is the order you have to choose. That means this is and this is. In the first one, that is 3 symbols z, y, x, in that order will be reduced to y, and x will be reduced to x finally. Therefore, the first integration. So directly now this function, the equation or the term appeared under the integral sign. Directly we do not have the answer, we do not have the ready formula to write, then we need to express this, that is root of 1 minus x square minus y square minus z square. How this problem is to be discussed, that is equal to, let I is equal to, I will rewrite the function inside in a different way, 0 to root of 1 minus x square and 0 to root of 1 minus x square minus y square, then inside, that is 1 divided by here. When z is the variable, simply you treat this 1 constant, yx constant and y constant. There should be minus of z square is there. Okay. Then under root you can rearrange 1 minus x square minus y square under root this one more square root sign you apply, that means whole square you can write, minus it is z square, minus it is z square. Then you will designate dz, it is dy and dx. This conversion why we have taken, this conversion why we have taken is to arrange or to compare with the known formula. That known formula is what? Known formula is, that is we have here I will write dx divided by root of a square minus x square. This is sine inverse x by a. This is the formula. So, to arrange or to accommodate that formula, known formula, we have rearranged the equation given inside the square root sign in this fashion, because under the root one more root we have taken, that is 1 x and y, all the three are considered to be temporarily constants. Then this is exactly of that type. Then the integration, now I will start integrate. Here z place as variable, remaining quantity is a constant according to this x. Then integrate with respect to z. That means you will treat x and y as it is constants both. At that time when you are integrating with respect to z, then x and y will have to be treated as constants. This is 0 to 1 and 0 to root of 1 minus x square. Then I can write this one as sine inverse x by a. That means z divided by square root of 1 minus x square minus y square, and this is between 0 to root of 1 minus x square, it is minus y square. Then which variable we have to assign? Dy, and then it is dx, because we are eliminating in the first integration z and by introducing the limits which are assigned to z. This is equal to 0 to 1 and 0 to root of 1 minus x square. Then in place of z the upper limit, in place of z you are replacing the lower limit. In place of z the upper limit is square root of 1 minus x square minus y square should be, that is sine inverse square root of 1 minus x square minus y square divided by square root of 1 minus x square minus y square, the upper limit, minus of sine inverse, it is 0 divided by square root of 1 minus x square minus y square. This is the application of upper limit and lower limit after the first integration. This is dy and then dx. Then you will write 0 to 1, then you will consider 0 to root of 1 minus x square, root of 1 minus x square. Then this you can cancel, and this quantity, that is sine inverse of 0. Therefore, sine inverse of 1 minus sine inverse of 0, it is dy and then dx. As you know that sine inverse of 0 is 0 and sine inverse of 1 is 90 degree, that is pi by 2. That is 0 to 1 and 0 to root of 1 minus x square should be pi by 2, and anyway it is 0, then dy and then dx. You can easily make out that problem which contains the function of this kind, and then we rearranged and then we brought it to this stage, the simple case. Earlier it was given with that kind of function, but now the function under the integral sign is only the constant, that is pi by 2. Then now we have to integrate with respect to x. I am sorry, integrate with respect to y. Integrate with respect to y, because x is appeared as one of the limits, then you will consider it as the case of integral with limits as variables. Therefore, x is constant. Then this is equal to 0 to 1, then pi by 2, then y, and it takes the limits as 1 minus x square. 1 minus x square should be, it is dx, pi by 2, integration 0 to 1, root of 1 minus x square, it is dx. Now you take the next step integration with your usual substitution method. What is the substitution you are going to apply in place of root of 1 minus x square? You have two options. One is replacing x by a sin theta, or replacing x by a cos theta, because you have the formula that is sin square theta plus cos square theta is equal to 1. You can express sin in terms of cos function or cos in terms of sin function. Therefore, anyone you can choose. Let me take x equal to, substitution I am choosing because you have to avoid this square root sign, x equal to sin theta, then dx equal to cos theta into d theta, then the limits at x equal to upper limit as 1, then theta is equal to sin inverse of 1, here 1, theta is equal to sin inverse of 1 should be 90 degree. This is one limit, and at theta is equal to lower limit, that is 0, then at x equal to 0, then theta is equal to sin inverse of 0, that is equal to 0, sin inverse of 0. Sin inverse of 1 is 90 degree because sin 90 is 1. Then your integral comes out to be, that is pi by 2 as it is, then 0 to pi by 2, it is square root of 1 minus sin square theta, then dx cos theta into d theta, then square root of 1 minus sin square is taken as square root of cos square theta, that leaves the quantity as cos theta, then which leaves the quantity as cos theta, then you will get under the integration, that is pi by 2 outside as it is, then 0 to 1, afterwards 0 to pi by 2, that becomes then cos square theta, it is d theta. Then you have to integrate the last term as cos square theta. You have two options again. One is reduction formula you can apply, otherwise cos square theta you can transfer in terms of trigonometric formula, that is 1 plus cos 2 theta divided by 2. Trigonometric reduction formula with trigonometric function as cos theta, that is here you can take it as 0 to pi by 2, the value of the definite integral 0 to pi by 2, that is cos to the power n theta d theta, where n is even. What is the formula you have studied in the previous syllabus? That is, when n is even means that is 2 minus 1 divided by 2 and multiplied by pi by 2. Like that also you can take. In any way you can manage, that is pi by 2 here. Then 1 plus cos 2 theta, in place of cos square theta you can write divided by 2 for the integration 0 to pi by 2, then it is d theta. So pi by 4 and integration should be theta plus sine 2 theta and divided by 2, carries the limits 0 to pi by 2. That becomes you are going to replace the limits theta equal to upper limit and theta is equal to 0, pi by 4, that is pi by 2 plus sine 2 theta. So theta is equal to pi by 2, that becomes sine 180 according to ASTC rule, sine 180, that means this is 0, this is pi by 2, this is 180 degree, this is 90 degree, pi by 2, then it is 270, this is 360. What is sine 180? That is 0. Then according to the lower limit application, theta equal to 0 and sine 0 is 0. That should be, that is pi by 8. This is your answer. So the final answer is I is equal to pi by 8 for that given problem. What we understood in this problem is, when triple integral is given with respect to 3 symbols, that is with respect to 3 symbols as 3 variables, then you have to consider the first innermost integral. You have to be very careful when you are choosing the innermost integral which is given with what kind of limits, second integral which carries what kind of limits, then third integral what kind of limits. We have understood from this the 2-3 cases, the constants limits were given, you can go for any order, variable limits are given, then according to the given variables you have to rearrange. In case if it is not given in the correct order, you have to rearrange the order of the derivatives in that particular fashion. That is I is equal to pi by 8 is the answer. And let me give one more case as the last one in handling this triple integration with one more simple example, then we can start the applications of double integral as well as triple integral. Let me discuss another case in the same fashion, that is triple integral with one more variable form. That will be, I will just give the hints for those problems so that you can go for the list of the examples we have shown here. This is another case, that is 0 to a and 0 to x and 0 to x plus y, that is e to the power x plus y plus z dz dy dx. That is exponential which you are taking here, e to the power of x, you can split e to the power of x into e to the power y into e to the power z. You will be integrating with respect to, in the similar fashion as we explained this problem, in the similar fashion, that is x plus y is there. So you have to assign in this case you have to assign the first integration should be with respect to z, and second integration should be with respect to y because x is appeared, and third integration, that is outermost integral, that is 0 to a, which takes the variable the remaining one. Here z is over for the innermost integration, this is z and then y is over, and finally this is 0 to a should be with respect to x. That means it is done here. E to the power of x, e to the power y, e to the power z will act as a product, that in the case of exponential as the base and the powers as x plus y plus z, all the three are the constants. Then all the three are the constants, then you will take the integration with respect to z first, then e to the power z you will integrate, and e to the power x and y will remain as constants. Then it goes the procedure, it goes like this only. Then here we have the list of examples for both double and triple integrations. Then the first problem you can see now, 0 to 1, 0 to root of 1 minus x square and 0 to square root of 1 minus x square minus y square, that is the function is given x, y, z, dz, dy and dx. Okay. In the next example that is given minus 1 to plus 1, 0 to z and x minus z and x plus z. So here some interesting observation is there, that is x plus y plus z dy dx and dz. In this case the innermost integration carries the limits, that is x plus z and x minus z means x and z will act in this innermost integration, x and z will act as variables. Then you cannot integrate with respect to x and with respect to z for the innermost integration. You have to integrate first with respect to y and then with respect to x, afterwards with respect to y. This is the order which you have to choose. Then this is the procedure where you have to follow. Then I will close this triple integration because we understood the cases how this triple integration behaves. Then as a last example I will write as polar coordinates. Here also polar coordinates problem, which I will write it as a sample, that is evaluate evaluate 0 to pi by 2 and 0 to a sin theta and 0 to a square minus r square and divided by a r into, here it is dr, d theta and dz. This is another sample which you have to consider, In this sample you cannot choose innermost integration with respect to r, because r is already given, so that you can go for z, this one, and then you can go for r, and then you can go for, that is theta. This should be the order. So first you must do that with respect to z, second you must do that with respect to r, third you can do that with respect to theta. I just want to give a break, and if you have got any questions you can ask me, I will answer it.